All right. Good afternoon, everyone. This is Charley Ferrari. I'm here in New York, and I'm going to be leading this webinar, connecting a data source using Plotly's Dash. So welcome everyone from elsewhere, and we'll get started. So let me just share my screen. And get started. So first, just to introduce Plotly. Plotly is a web-based data visualization platform for advanced analytics and modeling. Plotly was founded in 2013. Co-founders Jack Parmer and Alex Johnson. We are VC backed, so you could see a few of our VC partners listed there. And we're currently actually a growing team, around 25 people, depending on who's part-time, full-time, based in Montreal, but we do have several remote workers, myself included. And in describing Plotly, I like to talk about sort of a full ecosystem. Plotly really does have lots of different ways to use it. It could be used in a more business analyst use case for more ad hoc analysis. We have Chart Studio, which is a fully online chart creator, letting you upload CSVs or connect directly to databases. And then we have more data scientist oriented use cases. So we have our API, which you're able to access via Python, MATLAB, or R, as well as a few other open source connectors, Julia, Haskell, etc. And then what we'll be going through today, which is Dash. And Dash is a full application development framework centered around Plotly and really centered around Plotly with the goal of creating data-driven web apps. It's built on top of Flask framework, one of the two main web application frameworks in Python. So there's a few, so it's Flask on the back end, and it's oriented towards Plotly, so creating more data-driven apps. And just to sort of take a step back and put Plotly in context of the full BI and analytical landscape, Plotly really tends towards more complex use cases, and this is seen by the different APIs that we have to various data science programming languages. Plotly is open, so it works very nicely with a wide range of tools. But in terms of the sorts of personas that use Plotly, and especially those who would be interested in a webinar like this, it tends more towards the data science side and more complex use cases. Rob Williams is our VP Sales, and if anyone after this webinar has any questions, feel free to just contact him directly. And to get started on this webinar, this topic was really inspired by a common question that we get from our clients, which is just simply, what sorts of data sources can Dash connect to? And the reason why I found this to be an inspiration for something like this is because the question itself is not really the correct way of looking at Dash, and hopefully that'll be a bit clearer when we go through. Dash is, as I mentioned, built on top of Flask. It's fully within Python, so really anything that you could do in Python, you're able to bring into Dash. That's really where its main strength comes from. So So hopefully that'll be a bit more clear as we go through a few examples. And with that, we'll move on to these examples. So I have, I'll just be going back and forth between the code behind these examples as well as the finished results. And one other thing to mention, this isn't meant to be an intro Dash webinar. So we do have another previous webinars where you could get yourself up to speed on more introductory elements of Dash. This is meant to be more targeted towards connecting Dash to data sources. So with that, we'll get started. So as I mentioned, because Dash is in Python, you're able to connect it to any sort of data source that Python is ultimately able to connect to. So this first example, it's sort of the simplest example, just reading in a CSV. So this CSV is just remotely hosted on GitHub. I'm just using pandas to read it in. This is fairly straightforward in terms of the pandas workflow. And I'm just simply using this, this data frame in my Dash app. And I'll show the finished product, but first we'll just go through the code. So what we're actually doing here, we're looking at a data set of Walmart store openings. And from the layout, you could see that we have two elements. So all these are going to be relatively simple in terms of interactivity. Here, all we have is a graph and we have a slider. So when we're looking at Walmart store openings, we have the date, we have the year that it's opened, and this slider lets us sort of pick which year we're looking at and find out how many Walmart stores are open in that year. And so the layout sort of sets up the app, and then this callback is where we actually have the logic of the app. So all we're doing here is we have our slider, that's our input, which is coming in right here. And we just have our output map with slider, which is just going into this DCC.graph object. And all we're doing is filtering this data frame depending on the year that's coming in. So the slider is letting a user pick a year. What we're doing is we're bringing in that year. We're getting all Walmart stores that were opened in this year or before, and getting the latitude and longitude, and then plotting it out. So we're using scatter geo. So we're just plotting out points on a line map. And then we just have some additional information about the layout, which isn't changing. Well, actually, it is because it's updating the title. So that logic is straightforward enough. And the resulting app, as you could probably expect, it's fairly straightforward. We have a slider down here that lets us pick different years. It updates the map depending on which year is selected. So using this, you could analyze the pattern of Walmart store openings, starting from Arkansas to covering the whole country. So you could see, just sliding the slider like this. So our second example, on the surface, looks exactly the same. We have a slider, and it's updating the Walmart store openings. So in a lot of ways, this app is exactly the same as what we have, but on the back end, things are different. So here, we're pulling in data from a CSV. And here, this is probably the most common use case that we see with Dash. We're connecting to SQL. So here, I'm just using SQL Alchemy to connect to our demo PostgreSQL database, creating my connection, and then here the callback is slightly different. And what I'm doing is with this callback, each time the year changes, I'm building a new query. So so in this example, we brought in the data and we're simply using this to filter the data frame. Whereas here, we're actually doing the filtering on the SQL side. So we're sort of including this in a SQL format, in a SQL statement rather, formatting it with the year, bringing in the data. You can see we're not doing any filtering with pandas because we've already done that with SQL. And then everything else is very similar to what we had before. So in this new app, each time I'm making a, I'm toggling this date slider, it's making a SQL call. And this brings up actually a sort of key thing to think about when you are connecting Dash to data sources. One key difference is obviously one app is bringing in data from a CSV, another app is bringing in the data from SQL. But there's actually a more subtle and a subtle yet more important distinction. In this case, I'm actually just bringing in the data right in the beginning here. So I'm bringing in this Walmart data, and this code is actually ran when the app is first spun up. So if I'm just running it locally, just Python Walmart CSV .py, this data is brought in once, and then everything else is just simply done in memory. And the reason why this is an important distinction is because locally, if I'm just starting it and stopping it, it's always it's always sort of bringing in that data upon starting. But in most sort of enterprise uses of Dash, a Dash app like this is going to sort of be spun up and remain live. And in this app here, the data isn't being updated. So usually you don't associate a CSV with live data, but you could of course imagine this CSV could be, there could be a script updating this CSV on the back end. But for this app, if the CSV is updated, that doesn't mean the data would be updated. Because as I mentioned, this app is spun up, it's brought in the data, and it's just keeping that stale data. The SQL example is performing a new query, and the key is it's performing this query within the callback. So here in this slider, you could see I'm setting an initial value. This value is 1962. And based on that initial value, when a user first loads this app, the callback gets called with that initial value. So the first thing that happens is a user loads this app, the callback is ran, and the query is ran. So this could be a live database. This database could be continuously updated, as it is in many data science use cases, continuously updated. And as one would expect, anyone looking at this Dash app would be getting fresh data. And that's ensured by keeping the data call in the callback itself. And so we're just looking, right now, we're just looking at kind of more traditional data connection use cases. But this, because this is Python, and as I mentioned before, you're able to connect to anything that Python can ultimately get to. If you're using something like Beautiful Soup to scrape data, you could integrate that with a Dash app, and you're just simply using raw web data as raw scraped data as your your data source. Or in this example, I'm using some civic data coming from New York, and I'm using the Socrata API. So Socrata manages New York City's APIs, and you're able to pretty easily connect to city data sources. So in this case, what we're looking at is the New York City tree census, and we'll similarly to the first example, we'll just go through the code and then see what the live app looks like. So what we're looking at is this tree census. It's, as the name suggests, it's a record of every tree, or attempting to get every tree in New York City, logging different information about it. And what we're really looking at here is the species of the tree as well as the condition of the tree. So I am bringing in some data up here, and even though I'm doing that, you'll see that the app is still live. There is still data being brought in to the callback. This is really just to build my layout. So all I'm doing is getting a fresh list of tree species. So just looking at distinct trees and just getting a list of burrows. But those aren't changing, so I could have just hard-coded those. And in this layout, there's a bit more styling going on, but the real important elements that we're looking at here are two drop-downs. So we're selecting trees and we're tree species, and we're selecting burrows. And then we have a resultant graph div. And the reason why I included this as a graph div is because sometimes users can make selections where there are no trees of a specific species in a particular burrow, and in that case, I'm just giving a sort of displaying that information. So here, if the resulting data frame isn't empty, I'm going through the graph, and if not, I'm just going to say that there are no specific trees in a specific burrow. So what I'm doing here is with each callback, so we're looking at the tree species as well as the burrow. So each time one of these change, we're rebuilding the URL depending on what we're looking at. So the Socrata endpoints, they have sort of their own internal query language. So it's similar to SQL. So you could see we're just selecting some data. We're filtering it where the species and burrow name are defined here, and we're grouping it by the health of the trees. So we're going to get an aggregated data set once we run this. We're formatting it, and this is just some URL formatting because we're dealing with the URL here. So once we do that, we're just reading in the data, and assuming that we're getting data, we're going to build a pie chart. So we're going to look at the health of the trees and the count BBL. That's just the count of the number of trees with a specific type of health. And then I'm just adding a the for the Bronx. And once we, so that's what the code looks like. And the live app, which again, this is a relatively straightforward use case, so it's pretty easy to sort of see how this relates to the code. But we're actually looking at different tree types, and we're seeing what the conditions, sort of the relative conditions of these trees. So for each species and for each burrow, we're looking at what the sort of how good overall are these trees doing, and what the distribution is. And similarly to the SQL example, we are pulling in data in the callback. So this this data set isn't super live. I believe it's the 2015 census, so it shouldn't be changing that much. But obviously, there are always revisions to data, and this app could be deployed, and a user is ensured because we're pulling in the data in the callback that they're going to get this fresh data. So again, when you are looking at connecting data sources to Dash, really this this sort of including the data connection within the callback seems minor, but really that's key to making sure that you're ensuring your users are getting live data. So that's it for the content, and I'll come back over here, stop sharing my screen, and I'll answer any questions that people have. So there's both a ask a question link and the chat. So I'll begin reading from the chat just to answer some questions. So first question, Javier is asking how would Plotly integrate with a wider Flask application? So in a few ways, Dash could be a Dash app could always be served via an iframe. So you could always look at it in that way. In terms of and then the Dash app itself is always Flask app. At the end of the day, a Dash app is a Flask app. So a lot of settings that you may add with Dash apps come from that Flask backend. In terms of sort of more of the specifics, like the React front end and Jinja templating, we do. So it's not recommended to use fuller templates because really the interactivity of Dash apps is coming from each component being defined either in Dash core components or in Dash HTML components. So that's really the Flask integration would come into play when you're sort of changing Flask settings, and not really when it comes to templating. In terms of and then a few other questions. There will be so for those having trouble with resolution, there will be a recording of this, so you will be able to sort of rewatch this if you want. Should be optimized for Chrome, and I believe that's it. I'll one more question. So this is from Wes. Are there any suggestions on integrating with with this specific API, the Salesforce API? I don't have direct experience using it, but this is very similar to the Socrata example. So really the way to design an app like this would be to sort of think about what you want your app logic to be and your layout. Work on it from that angle, and then and then sort of keep in mind that you would want these Salesforce API calls to be within the callbacks. So if you're filtering on client type, and that's a field that you're using for the Salesforce API, you would sort of be querying that API in the callback, taking in the client type or client ID. And then from Doug, how can this be deployed with Django? With Django, there's less, because Dash is based on Flask, it works a bit more easier with, Flask integration than Django. So in an existing Django app, Dash could be sort of served in an iframe. And then just sort of looking at it from another angle in terms of deployment. A Dash app is most of the time used as a standalone app, and any place where you're able to deploy Flask apps, you could deploy Dash apps. On our documentation, we have an example going through Heroku, and of course we have Dash on-premise servers, which allow you to sort of deploy Dash apps on your own enterprise servers. And then from Salmon, the prints jumbled up. So Salman asked that prints jumbled up. That wants the Dash app to look pretty on the screen, but there's looks like text formatting issues are occurring. And what I would do is I would look at a few of the examples on the documentation. In particular, I would look at the Markdown Dash core component and the Markdown. So with Dash apps using the Markdown core component, you're able to style text using just Markdown. Alternatively, you could use any HTML tag. So if you're using things like H2P, things like that, you could style your apps. You could style your text that way. And in some of the Markdown examples, you'll see how the text is formatted within the code, and that'll sort of give some guidance on how to on how to style these. And in terms of the charts being cropped, there's a lot that could be causing charts to be cropped in that way. By default, like Plotly charts are meant to really fill in whichever container you give it, and things could be going awry if perhaps a graph is being put in a container that's too small, and the styling of the graph itself becomes wonky. I would look at the main Plotly, so plot.ly/Python. I would look at that main documentation, which will show which will sort of show in each of the graph types. It shows you how to, usually has a styled example, so it'll go through a few examples like that. And then plot.ly/Plotly/Python/reference will show the raw reference. So you'd be able to see each of the specific settings that you could set, and so that would be really where to go in terms of styling. So things like if your legend is taking up too much space and it's detracting room from the graph itself, you could really there's a lot of different ways: styling the container of the graph itself or styling the individual elements within the graph. And then there was another question here. Dash can work with custom components. So in terms of Jinja templates, we do have and I'm not remembering the name off the top of my head, but there's a core component where you're able to enter in raw HTML, and so it's like we have gotten this question a lot, and we've included this core component for raw HTML, even though it's something that we don't really recommend because of the way Dash deals with the interactivity. And I don't think that would really work. Well, I mean, actually, yeah, that would sort of be kind of more of a template style, but really the best way to think of Dash app templates would be to if you are trying to standardize the production of Dash apps, you would be able to have reusable sort of custom. So kind of when I say custom components, I mean sort of collections of like a header, which is a collection of HTML components, and this would be sort of defined within Dash. You could sort of make these components reusable. app to app. So that's really how I would recommend sort of working with templating in that way. And so this is another question from the Ask a Question module. So what is the correct way to handle large data sets? And that is a great question. The really the way to deal with large data set, and actually just to take a step back, working with Dash, it really you need to sort of be in the mindset more of a web developer than what you may be used to as a data scientist. You may be used to working in a Jupyter notebook and knowing that a certain query will take time. So you may sort of be working with it in that way, save what you want in memory, and then sort of work with it in that way. So sort of thinking about the large data sets, you want to think about sort of that user experience. So if I do have a SQL query that's going to take minutes to run, I perhaps wouldn't want to include that in a callback or in a frequently called callback. I may want to sort of design my callback such that I make one call in the beginning once the app's loaded, and then I'm filtering it more in memory. And then another thing to think about is the way I was using the Socrata API. Those data sets are pretty can be pretty large, and actually using the Socrata API, they limit it by 1,000 records, which if I were to naively bring in every single tree in a table in a pandas data frame, I would have to page through all of these results. And if I were to do that, it ends up taking a very long time. And that wouldn't be ideal for a Dash app experience. But Socrata's backend is doing the aggregation for me. And you saw in that group, sort of that group portion of the query, I'm grouping the data on Socrata's end, and then just simply getting my aggregated table. So that's another, and the reason why I'm sort of using that as an example is because that's another way of kind of thinking more like a web developer, where you have, sort of your backend, in this case, the Socrata backend. I'm using that to do my aggregation, and I'm bringing that aggregated data into Dash. And there are there are tons of databases that are optimized for doing these sort of big data aggregations and things like that. And the way to integrate a Dash app with that would be to keep the aggregation on the optimized database, and then within the Dash app, sort of bring in that aggregated data, if that makes sense. And then there's another question: how can multiple users access Dash apps? We have a section on this going through this in the Dash documentation, where it really talks about where it talks about global variables, and it kind of explains that Dash apps are really meant to be stateless. Especially in the examples I was using, the data is getting called in these callbacks. So these apps are truly stateless. Actually, the CSV one, not so much, but looking at just the SQL and Socrata examples, those apps are truly stateless. So if I do have the app deployed, and I'm using something like GUnicorn to sort of allow multiple users to hit my app, multiple users will be able to hit it, and they won't be, their selections won't be conflicting with each other. So basically the multiple users, that comes in with how you're hosting it, and if you're allowing multiple users to hit it, but it's the statelessness of the Dash app that allows multiple users to interact with Dash apps and not sort of conflict with each other. And then from SK, so I didn't cover streaming this time. There's a component called DCC.interval, and DCC.interval would be how you would sort of do streaming. So what DCC.interval does is it allows you to set a time frame, so you could sweep every second, let's say, and it will and it's a callback like any other. So all the interval is saying is every second run this callback. That callback could be querying a database, and then the data will be brought in fresh. So that's how streaming works with Dash at the moment. It's not set up with WebSockets just yet. So right now it's really through that DCC.interval component. And then we have yes. So Dash does allow CSS styling, and actually in the apps I was using Bootstrap to, or actually I was using Grid CSS, but Bootstrap is included with our sort of just we have a sort of recommended standard CSS if you're just not sort of if you don't want to really deal with CSS, but it allows you to use sort of Bootstrap style formatting. And then we have from Lakshmi, there's a specific example using tabs and radio buttons. So the way to think about something like this, and this is similar to the question I answered before about big data sets. So sort of the long time that you're noticing these apps are loading is probably due to the fact that there's some expensive, obviously there's some expensive operation. A lot of times that expensive operation is the data query itself. And the way to think about styling an app or designing an app in that way is to sort of think about the interactivity of your app and try to essentially try to avoid expensive calls whenever possible. So we have a section in the Dash documentation that goes through sharing data between callbacks, and that's really the way that something like this would be done. So sort of imagining a toy example. Imagine you have kind of imagine that the tabs are sort of triggering an expensive query, and the radio buttons perhaps you don't want to also trigger that expensive query. And what you could do is use the tab to pull the data, the most common way of doing this is to put that data in a hidden div. This is explained a bit more in depth in this documentation that I pointed out. So you put the data in a hidden div, and then you access that data from a second callback. So really the way that looks in terms of this design is a user makes a selection with the tab. That tab is sort of triggering the expensive callback, or the expensive query, and then that data gets saved, gets cached in a hidden div, and then in this example, the radio buttons would be simply using that hidden div. So in that way, you're avoiding the callback. You're sort of avoiding that, sort of calling the expensive query on every single callback. You're only calling it on the tab callback. And these could get, my examples were very simple, but this can get complicated, and there's, sort of a lot of ways that, you could think about sort of these chains of, app logic. So, so I would look up that sort of sharing data between callbacks, and hopefully that would sort of give you an idea of how to reduce the loading time on all of your callbacks. And it looks like we have this follow-up from one of the questions. Yes, so Dash does support custom components, and so all Dash's front end is built on top of React, and so any Dash component is a React component. So there's a in our documentation we have sort of the we have kind of the template to create custom components. Basically, if you find a React component out there, if there is a particular way of interacting with a site that you see, then you're absolutely able to write it as a custom component, and then sort of define how Dash is going to interact with it. So define like what your different like how Dash is going to define this this component, and then you'd be able to use that in Dash. And I believe that's it. So thank you everyone for attending. If anyone does have any questions, feel free to go to our Dash community, or our Plotly community, community.plot.ly, and you could ask your questions there. But thank you so much, and take care.